In this video, I'm going to talk about stable diffusion, in particular automatic 1111. I'm going to basically split it into 2 or 3 videos, but essentially I'll talk about a little bit of the history, how it's developed to where it is now, and then I'll go into installing this application that you see running. So I've got a local install of it, a very simple prompt. I can hit generate and I can just get infinite random pictures of cats in hats. So I'll go through how to get this all up and running, and I'll also go through the terminology, the features, maybe some more of the extensions, the advanced stuff that you can do with it. So there's a list of papers here that over the years have been very pivotal. There's probably quite a lot more outside of this, but these are the ones that I picked out through things that I've been reading. One of the main ones was the Generative Adversarial Networks in 2014 by Ian Goodfellow. This was the sort of go-to way to generate images through AI before Stable Diffusion came along fairly recently. So just to explain how it works, a generative adversarial network is essentially two neural networks. So you've got a generator and a discriminator, and they're pitted against each one another. So the generator's job is to produce images that are as close to the source and training data as possible, and they need to fool the discriminator. The discriminator is getting samples from the generator every so often, but also from the real images from that training data. It doesn't know which is which. All it does is just classifies them. It just says, is this a real image? Yes or no. And it spits out a 1 or a 0. And that information is getting fed back to the generator, and then it can learn what works and what doesn't work and just improve over time, or at least that's the idea. It was quite a long-winded process, quite an intensive process, and there were some issues with this, but it has been effective in some areas. It's been applied to quite a lot of applications. So I think Imagen was based on this, and there was a few other applications as well. But really, things completely changed when Stable Diffusion came along, and the architecture was very different. So we've just got one self-contained process. There's not two neural networks anymore. But basically what's happening, and just actually before I go into this, if we go back to GANs, this is all happening, I think I mentioned, in the pixel space. So if you have a 512 by 512 image, even if you reduce that down to 64 by 64, that's still however many pixels that you've got. And then each one of those might be red, blue, or green, and obviously a variation of that. So it's a lot of data points and it's quite intensive. So this process was never really that accessible to everyone like Stable Diffusion is now. So Stable Diffusion, we have the input images up here on the left. So let's say this is a 512 by 512 image. Again, it's reduced down to 64 by 64. But at that point, it's compressed into a much more efficient data stream, which is in the latent space. So what that means is we're no longer looking at the pixels, we're compressing that information into sort of a much more condensed format. And it's, I think, 48 times, effectively 48 times smaller than dealing with that pixel space. So it's a representation in data of the image. So you have this image in latent space, and there's a diffusion process, and that's literally just adding noise. So over time, we add noise a little bit at a time until we end up with an image completely full of noise, and it's not recognizable. So it's just Gaussian noise added. So the idea with a stable diffusion is that we have this sort of granular way of adding noise and a recorded method, but then it's reversed, and the neural network learns how to remove that noise. So we have the image full of noise here, and then over time, over steps, it's just removing noise a little bit at a time until it gets back to the original image, and it's learning how to do that. It's a lot more computationally efficient to remove noise than it is to try and generate an entire image. The other thing that's going on here is this sort of stepped process is called, it's done by the sampler, and that's because it produces samples each time. Where the image is converted actually and compressed into this latent space representation, that's happening by the VAE, so that's the variational autoencoder. And these terms I'm just specifically mentioning because they do come up within Stable Diffusion. So the VAE encodes the data from pixel space into latent space, and then vice versa at the opposite end. So so we've got the VAE, the encoder. We've got the sampler, which removes noise, and the steps over time. And I think really that's the main bunch of terms that you'll need to really understand when you're working with the front end. I mean, you don't really even need to understand them, but I'm just calling them out, and it'll make sense later. The main point to take away here from my grossly oversimplified version of trying to explain what stable diffusion is that it's just removing noise step by step to get an image. So when you look at the UI, you'll see there's a sampling method. So there's different methods designed to remove that noise from an image, and sampling steps. So the amount of steps it removes noise from over time. And then we've got models and checkpoints as well. And that is effectively the training data, the data model. So a company, and this is really where it all took off open source wise. There was a company called Stability AI that raised all the funds and from various investors, and they trained this model based on 5 billion images. And it's by Lion, which is a German non-profit, and they actually released these data sets to enable that to happen. So you've got these image caption pairs, 5 billion images, and this method of training models based on that diffusion process. It cost about $600,000 supposedly to create this open source model. And when you install this, you'll get 1.5, which is what that is based on, that initial training data. And they've since released a second one, version 2, which is trained on slightly bigger images. So you'll notice the width and the height in here by default is 512 by 512. All the training data was 512 by 512, so it's sort of designed to work with that size. So when Stability AI came along and released the model for this, it made it really just publicly accessible. That was the real main part that stopped the average person, just anyone just from training this because of that cost implication. And now you've got tons of models out there. So if you look at a website like Civitai, which is one of the best ones in my opinion to find resources for this, you can download custom models. So here I've got it listed by highest rated of all time, and there's different models for different styles. We've got a good all-rounder. There's one for a more animated look. There's one for sort of these painted watercolor type looks. So there's all these different styles that the models are fine-tuned and trained and merged towards. But if you go into these, you'll notice on the right hand side it gives you some metadata, some information when it loads. So we've got the base model here. So all of these models are actually based on that open source, the base model that Stability AI released. And that's really what has made this accessible to everyone, because that initial training has been done. It's just a case of then people fine tuning it and creating variations of it. So that pretty much summarizes, I think, the brief history. In the next video, I'll go into actually installing this. Obviously, there's lots of image generators out there from DALL-E 2, Midjourney, Imagen, but they are based on these same technologies really under the hood. They just work in a slightly different way. So I'll explain Automatic 1111 and the process of installing it, the hardware requirements, all of that stuff. and I'll go through all the features and then how to use it in the video after.